Right now, somewhere on a battlefield, a T-55 is either being fired in anger or sitting behind a berm waiting for the order to move. That sentence would be unremarkable if we were talking about 1967 or 1973 or even 1991, but we are talking about 2026. A tank designed before the first artificial satellite ever left the Earth is still considered a combat-relevant weapons system by dozens of armies across 4 continents. That is not a curiosity. That is one of the most extraordinary engineering achievements in the history of armored warfare, and it demands an explanation. The T-55 is not famous because it is the most sophisticated tank ever built. It is not famous because it carried the most advanced sensors, or the most powerful gun, or the thickest armor. It is famous because of something far more difficult to engineer than any of those things. It is famous because it worked, consistently, reliably, affordably. In deserts and jungles and frozen steppe, in the hands of conscript armies and elite armored divisions, maintained by mechanics with almost nothing, and operated by crews with minimal training, the T-55 delivered. It delivered firepower when firepower was needed, mobility when mobility was decisive, and protection when protection meant the difference between a crew coming home and a crew becoming a statistic. But here is what the numbers alone will never tell you. The T-55 is not just a machine, it is the physical embodiment of a doctrine, a philosophy of war, and a vision of what armored power should be that stood in direct opposition to everything the Western Alliance believed about tanks during the Cold War. Understanding why the T-55 was built the way it was built requires you to step inside the mind of the Soviet military establishment in the years immediately after the Second World War, and to see the world through the eyes of men who had watched 27 million of their countrymen die in the most destructive land war in human history. Those men were not going to build a tank for peacetime parades. They were going to build a weapon for the war they knew was coming, and they were going to build it in numbers that would make the entire concept of individual tank superiority irrelevant. This is the complete story of the T-55, where it came from, what it weighed, measured, and carried, how it performed on the battlefields where history was decided, why it outlasted every tank that was supposed to replace it, and every army that was supposed to destroy it, and what the lessons of its extraordinary 70-year service life tell us about what armored warfare actually is when you strip away everything except the fundamental question of what wins and what loses. Stay with me, because by the end of this, the way you think about tanks will never be quite the same. To understand the T-55, you must first understand the T-34, because the T-55 is in a very real sense the answer to every question that the T-34 left unanswered. The T-34 was a revelation when it appeared in 1940. Its combination of sloped armor, wide tracks, and a powerful diesel engine made it the most conceptually advanced tank of the early Second World War, and it shocked German tank designers profoundly when they first encountered it in the summer of 1941. But by 1943, the T-34's initial advantages had been neutralized by German countermeasures, and the Soviet design bureaus knew that the war had already made it obsolete as a long-term platform. In 1943, the Morozov Design Bureau in Kharkiv, Ukraine, began development of what would become the T-44, a tank that addressed the T-34's fundamental layout problems. By using a transverse engine mount, a torsion bar suspension system, and eliminating the hull machine gunner's position, they created a tank that was significantly more compact and better armored than the T-34 while maintaining comparable mobility. But the T-44 arrived too late to see meaningful combat, and its designers were already looking beyond it. The specific question they were trying to answer by 1945 was this: how do you put a 100mm gun into a tank that is still light enough, fast enough, and cheap enough to be built by the thousands? Because in the Soviet military doctrine that emerged from the Second World War, quantity was not just a factor in the equation. Quantity was the equation. The prototype that answered that question was completed at the Uralvagonzavod factory in Nizhny Tagil by the end of 1945. It was longer than the T-44 by approximately 40 centimeters, slightly wider, and it carried the 100mm D-10T rifled gun in a new hemispherical turret inspired by the IS-3 heavy tank's distinctive design. This machine entered service officially in April 1946 as the T-54, and it immediately demonstrated both remarkable promise and equally remarkable production problems. Early units were plagued by quality control failures that halted and restarted production multiple times between 1946 and 1949. By the time the T-54-2 entered production in 1949 with a revised turret and improved mechanical reliability, the design was finally ready to be manufactured at the pace that Soviet military doctrine demanded. Through the early 1950s, successive refinements produced the T-54A and T-54B, each adding critical capabilities. The T-54A introduced a gun stabilizer in the vertical plane, the first generation of night vision equipment for the driver, and snorkel equipment allowing the tank to ford water obstacles up to 5.5 meters deep. The T-54B added a two-plane gun stabilizer, allowing the main gun to be aimed accurately, even while the vehicle was moving at speed, a capability that most Western tanks of the same period did not yet possess. These were not incremental improvements. They were qualitative leaps that transformed the T-54 from a capable but crude weapon into a genuinely modern combat system. But the designers at Uralvagonzavod, now led by Leonid Kartsev, understood that the evolution wasn't finished. The nuclear battlefield was coming. Soviet researchers had tested tanks against nuclear detonations, and the results were clear. A tank could survive the blast wave of a tactical nuclear weapon at reasonable distances, but the crew could not survive the radiation, and the unprotected mechanical systems could not survive the electromagnetic and thermal effects. If the next war was going to be fought under nuclear conditions, which in 1956 was not a theoretical concern, but a practical certainty in Soviet military planning, then every tank on the front line needed to be sealed against radiation, chemical agents, and biological contamination. That requirement, combined with persistent demands for more ammunition, a more powerful engine, and better reliability in extreme weather conditions, produced what would become the most important single military vehicle of the 20th century. The design was designated Object 155 internally. On January 1, 1958, it entered production at Uralvagonzavod. On May 8 of the same year, the Soviet Army accepted it officially into service. The world's armies would spend the next 40 years trying to catch up with it. They called it the T-55. To truly understand what the T-55 represented in 1958, you need to look at every number, every dimension, and every system with the eyes of a military planner who is trying to figure out how to equip an army of millions for the most catastrophic possible war. Because when you look at the T-55 that way, every design choice reveals itself as a calculated answer to a specific strategic question. The T-55 in its standard production configuration is a machine of deceptively compact dimensions. The total length with the gun pointing forward is 9 meters exactly. The hull itself, measured without the gun, is 6 meters and 2 centimeters long. The width is 3 meters and 37 centimeters, narrow enough to fit on standard Soviet railway flat cars without modification, a logistical consideration that saved incalculable amounts of time and infrastructure investment in a country spanning 11 time zones. The height to the top of the turret is 2 meters and 40 centimeters, dramatically lower than its Western contemporaries. That low profile was not an accident. It was a deliberate design choice that reduced the tank's radar cross-section, reduced the visible target it presented to enemy gunners, and allowed it to use terrain for concealment in ways that taller vehicles simply could not. The combat weight of the standard T-55 is 36 metric tons. This figure places it firmly in the medium tank category by the standards of its era, significantly lighter than the American M48 Patton at 44 tons or the British Centurion at 51 tons. That weight differential had profound operational implications. The T-55 could cross bridges that would collapse under heavier tanks. It placed less stress on road surfaces during long road marches. It consumed less fuel per kilometer. And in a doctrine built around the concept of rapid, deep armored penetrations into enemy territory, every ton of unnecessary weight was an enemy of operational success. The armor protection of the T-55 reflected the same philosophy of efficient optimization rather than maximum absolute thickness. The turret front armor reaches 205 millimeters of cast steel, sloped at angles that increase the effective resistance significantly beyond the nominal thickness. The turret sides carry 130 millimeters of armor, the turret rear 60 millimeters. The whole front glacis plate is 120 millimeters thick, set at a 60-degree angle from the vertical, which produces an effective protection equivalent to well over 200 millimeters of vertical steel against kinetic penetrators. The whole upper sides are 79 millimeters, the lower sides 20 millimeters, the whole roof between 16 and 33 millimeters depending on location, and the whole bottom 20 millimeters. The interior of the T-55A variant was lined with a plasticized lead anti-radiation compound that added meaningful protection against the neutron flux produced by nearby nuclear detonations, the first time any production tank in the world had incorporated this specific form of crew protection. The heart of the T-55 is its V-55 engine, a direct descendant of the legendary V-2 diesel that powered the T-34 2 decades earlier, and that represented the most robust and field-maintainable power plant in Soviet armored history. The V-55 is a V12 water-cooled four-stroke diesel of 38.88 liters displacement, producing 580 horsepower at 2,000 revolutions per minute. This gives the 36-ton vehicle a power-to-weight ratio of approximately 16 horsepower per metric ton, sufficient for a maximum road speed of 51 kilometers per hour and a cross-country speed of between 25 and 30 kilometers per hour depending on terrain conditions. The operational range on internal fuel alone is 325 kilometers on roads, but the T-55 was designed with provisions for two jettisonable external fuel drums mounted on the rear hull, each carrying 200 liters, which extended the operational range to approximately 610 kilometers. In an Army doctrine built around deep operational penetrations, that range was a critical strategic asset. The transmission is a mechanical synchromesh unit with 5 forward gears and 1 reverse, manually operated by the driver. The suspension is a torsion bar system with 5 large road wheels per side and no return rollers, giving the vehicle its distinctive low, flat profile. Ground clearance is 425 millimeters, adequate for most battlefield terrain, but not exceptional by modern standards. The track width is 580 millimeters, producing a ground pressure of approximately 0.81 kilograms per square centimeter, low enough to allow operations on soft ground that would bog down heavier vehicles. The main armament of the T-55 is the D-10T2S 100mm rifled gun, an evolution of the same basic weapon that had proven itself on the T-54 series. The T2S designation indicates the two-axis stabilization system, the TSY-clon, which allowed accurate fire while the vehicle was moving at speed. The gun carries 43 rounds in the standard T-55, with 18 rounds stored in so-called wet containers integrated into the hull fuel tanks, a layout that raised some concerns about fire risk but significantly increased the ready ammunition supply compared to earlier designs. The ammunition types available for the D-10T2S are extensive and evolved significantly throughout the tank's service life. The original complement included APT armor-piercing tracer rounds, APH armor-piercing high-explosive rounds, heat high-explosive anti-tank shaped charge rounds capable of penetrating 390 millimeters of steel plate, HE-frag high-explosive fragmentation rounds for use against infantry and light vehicles, and APDS armor-piercing discarding saboteur rounds introduced in 1967 that could penetrate 275 millimeters of armor at 2 kilometers range. The rate of fire for a well-trained crew is 4 rounds per minute, achieved through manual loading by the loader crew member, whose physical strength and training speed were direct inputs into the tank's effective firepower. The secondary armament consists of a 7.62mm PKT coaxial machine gun mounted alongside the main gun in the turret, with a 3,500 round ammunition supply. Later T-55 variants, specifically the T-55A and its successors, reintroduced a 12.7mm DSHK heavy machine gun on the commander's cupola hatch ring for anti-aircraft and anti-helicopter defense, a feature that had been controversially removed from the original T-55 production version on the grounds that it was ineffective against high-performance jet aircraft, a decision that was later partially reversed as helicopter gunships became a significant threat. The fire control system of the T-55 in its basic form was relatively simple by Western standards of the period. The gunner used a TS-H2B 32P telescopic sight for daytime engagements, with a magnification factor that allowed effective target identification at ranges up to 2,000 meters. The TPN-12211 night vision sight was added progressively through the production run, using active infrared illumination from a mounted L2 lunar searchlight to allow engagements at ranges of up to 800 meters in total darkness. From 1974 onward, production T-55 and T-55A tanks received the KTD-1 or KTD-2 laser rangefinder mounted in an armored box above the gun mantlet, which dramatically improved first-round hit probability at longer ranges by eliminating the ranging error that had been one of the weapon system's most significant operational limitations. The crew of 4 consists of the commander, gunner, loader, and driver. The commander occupies the left side of the turret with a rotating cupola providing all-around observation through multiple periscopes. The gunner sits forward and below the commander on the same left side of the turret. The loader occupies the right side of the turret and is responsible for selecting and chambering the correct ammunition type on demand. The driver sits in the hull's front left position and operates the vehicle through a tiller bar steering system. The NBC protection suite of the T-55A, the most significant single improvement over the original T-55, consists of the PARS radiation detection system that automatically seals the vehicle and activates the filtration system within 0.3 seconds of detecting gamma radiation, a full FVU overpressure chemical filtration system, and the anti-radiation lead compound lining of the interior surfaces. The unit export price of the T-55 to Soviet client states was approximately $200,000 per vehicle in the late 1950s and early 1960s, a figure that represented extraordinary value for the capability delivered. For context, an American M48 Patton cost approximately $250,000 per unit in the same period, while the British Centurion Mk10 cost over $300,000. The T-55's price advantage was not trivial for developing nations with limited defense budgets, and it translated directly into significantly larger fleet sizes for the armies that chose it. The T-55 did not remain a static design. Over its production life and subsequent service decades, it spawned one of the largest and most diverse families of variants in armored vehicle history, ranging from incremental improvements to fundamental rebuilds that shared little more than the basic hull geometry with the original 1958 production vehicle. The T-55 itself was the baseline, introduced in January 1958, representing the basic Object 155 design with the V-55 engine, 43-round ammunition load, and notably without an anti-aircraft machine gun, a decision that was immediately controversial. The T-55K was a command variant produced from 1959, fitted with an additional R1112 radio set and a charging unit for extended communications operations, at the cost of reducing the main gun ammunition load to 37 rounds and removing the bow machine gun. The TO-55, produced until 1962, was a flamethrower variant that replaced the coaxial machine gun with an ATO-200 flame projector and carried 460 liters of flammable compound in special tanks, replacing the forward hull fuel tanks, intended for use against fortifications and infantry in built-up areas. The T-55A, entering production in 1963, represented the most significant early upgrade and corrected several of the original design's most criticized deficiencies. The hull was lengthened by 16 centimeters to 6.2 meters, weight increased to 38 tons, and the full PARS FVU NBC protection suite was fitted as standard, making it the first production tank in history equipped with comprehensive protection against nuclear, biological, and chemical warfare conditions. The anti-radiation lead lining was added throughout the fighting compartment. The bow machine gun was removed to create space for 6 additional main gun rounds. The 7.62 mm coaxial SGMT machine gun was replaced by the more modern PKT. These changes collectively addressed the tank's most serious survivability limitations in the expected nuclear battlefield environment. From 1970 onward, surviving T-55 and T-55A vehicles were progressively updated through the service with the addition of the loader's hatch ring mount for the 12.7 mm DSHK heavy machine gun, laser rangefinders beginning in 1974, improved R-12-3M radio sets, and rubber side skirts on later production runs. The T-55M program, initiated in the 1980s, represented a comprehensive midlife upgrade that added the Volna fire control system with a ballistic computer and the TPNB-129 night sight, the Bastion system of anti-heat passive applique armor on the hull and turret front, provision for KMT-6 mine-clearing plows, and the option for reactive armor packages. The T-55AM introduced Contact 1 explosive reactive armor tiles on the turret and hull front, dramatically improving protection against shaped charge warheads that were the tank's most acute vulnerability. The T-55MV and T-55AMV variants combined all of these improvements into a comprehensive upgrade package that, on paper at least, brought the basic 1958 design's protection levels to within reasonable range of 1980s main battle tank standards against specific threat types. The Czechoslovak T-55AM2, produced from 1987, was arguably the most sophisticated Warsaw Pact upgrade of the type, featuring a completely new Kladovo fire control system with a laser rangefinder, ballistic computer, and crosswind sensor, combined with passive add-on armor and a new engine air filter system. Approximately 400 were produced, and they represented a genuine qualitative step beyond the Soviet upgrade packages in terms of engagement accuracy and crew situational awareness. The Russian T-55M6, the most advanced upgrade package ever offered for the type, featured a new longer chassis, a 690 horsepower engine, a completely new turret derived from the T-72B, explosive reactive armor throughout, and a modern fire control system with thermal imaging. It represented a philosophical question about how far you can upgrade a platform before it ceases to be what it started as, and the answer in the T-55M6's case was very far indeed. Beyond the Soviet Union and Warsaw Pact, licensed and unlicensed derivative designs multiplied the T-55 family across the globe. China produced the Type 59 as a direct copy of the T-54A beginning in 1958 and subsequently developed the Type 69 and Type 79 as indigenous evolutions that diverged significantly from the Soviet original while maintaining the same basic heritage. Egypt's Ramses II program, developed in cooperation with American companies, fitted a T-55 hull with a new 105mm Royal Ordnance L7 derived gun, a Detroit diesel engine, and Western fire control systems to create a hybrid that embodied the entire Cold War's technological competition in a single vehicle. Peru, Romania, Finland, and several other nations developed their own national upgrade programs tailored to their specific operational requirements and industrial capabilities. By any reasonable count, the T-55 family encompasses more than 30 distinct production variants and upgrade configurations, making it not just the most produced tank in history, but also among the most diverse in its operational configurations. Numbers on a specification sheet tell you what a tank is designed to do. Combat tells you what it actually does under the irreducible pressure of enemy fire, equipment failures, extreme weather, and the human factors that no engineering calculation can fully account for. The T-55's combat record spans more than 6 decades and more than 50 countries, and it is simultaneously a story of extraordinary operational success, significant tactical vulnerability, and the kind of hard-won battlefield lessons that shaped armored doctrine for a generation. The T-54 and T-55 families' first significant operational test came not in a conventional conflict between peer armies, but in the streets of Budapest in October and November 1956, when Soviet forces crushed the Hungarian Revolution. The performance there was mixed in ways that provided genuinely valuable lessons. Hungarian freedom fighters, equipped with nothing more sophisticated than Molotov cocktails and a few anti-tank guns, managed to destroy a number of T-54s using techniques that exploited the tank's fundamental vulnerabilities. The limited gun depression that prevented the main weapon from being aimed at targets at close range or below the vehicle. The crew's restricted vision from within the closed vehicle, and the catastrophic nature of internal ammunition explosions when a penetrating hit was achieved. These lessons were not ignored, and they directly influenced the T-55A's improved design priorities. The Indo-Pakistani War of 1971 provided the T-55 with its most demanding conventional combat test, and the results established its reputation as a serious fighting vehicle when operated by trained crews in appropriate tactical conditions. Indian Army armored regiments equipped with T-55s fought Pakistani forces equipped with American M47 and M48 Patton tanks in a series of engagements along the Western Front. The Battle of Basantar in the Shakagara Bulge sector, fought from December 4th to December 16th, 1971, became one of the most intense armored engagements since the Second World War, with hundreds of tanks and anti-tank guns engaged across a heavily mined battlefield in conditions of extreme cold and contested air superiority. The Indian T-55 force, operating as part of a combined arms effort with infantry, artillery, and engineering support, systematically breached the Pakistani defensive lines and advanced more than 50 kilometers into Pakistani territory. The Pakistani M47 and M48 Pattons were formidable opponents, comparable to the T-55 in firepower and protection, but the Indian crew's training and the T-55's superior mobility on the soft agricultural terrain of the Punjab proved decisive. Pakistan lost 47 tanks at Basantar alone, compared to Indian losses that were significantly lower. The T-55 came home from the 1971 war with an established combat pedigree that no amount of Western skepticism could dismiss. In Vietnam, the T-55 served with the North Vietnamese Army's armored formations during the final years of the conflict and played a direct role in the decisive campaigns that ended the war. The fall of Saigon in April 1975 is perhaps the T-55's single most iconic historical image, with North Vietnamese T-55 tanks crashing through the gates of the presidential palace in Saigon as the South Vietnamese government collapsed. But the tank's role was not merely symbolic. Throughout the Ho Chi Minh campaign of early 1975, NVA armored formations equipped with T-54s and T-55s executed a series of deep penetrations that overwhelmed South Vietnamese defensive lines faster than any military analyst had anticipated. The T-55's combination of firepower, mobility, and mechanical reliability in the tropical conditions of Southeast Asia proved well suited to the offensive operations that the NVA doctrine demanded. The battle for Xuan Loc in April 1975, the last major engagement before the fall of Saigon, saw T-55s operating as the armored backbone of NVA division-level attacks that, despite fierce South Vietnamese resistance, ultimately achieved their objectives through the relentless operational pressure that only a properly employed armored force can generate. The Angolan Civil War from 1975 onward provided a different kind of combat testing, one that revealed both the T-55's strengths and some of its most acute vulnerabilities in a completely different operational environment. Cuban expeditionary forces operating in support of the MPLA government deployed T-55 and T-54 tanks that provided the firepower advantage that allowed the MPLA to defeat UNITA and South African interventionist forces in the initial phase of the conflict. In the flat, open terrain of southern Angola, the T-55's long-range gun gave Cuban MPLA forces a decisive edge over opponents equipped with lighter weapons. At the Battle of Ebo in November 1975, Cuban T-55s engaged South African armored cars and achieved results that demonstrated the fundamental principle that a properly supported main battle tank, even one designed in the late 1950s, retains overwhelming firepower superiority over lighter combat vehicles in open terrain. The Afghanistan War from 1979 to 1989 delivered the T-55's hardest lessons. Soviet forces initially deployed approximately 800 tanks in 39 battalions, including significant numbers of T-55s for the invasion and initial occupation. In the conventional phase of operations, the T-55's firepower and armor made it effectively impervious to anything the Mujahideen initially fielded. Cities and valley floors were tank country, and the T-55 dominated them completely. But Afghanistan quickly demonstrated the universal truth that tanks without adequate infantry support in complex terrain are vulnerable in ways that their armor and firepower cannot compensate for. As Mujahideen fighters learned to use mountainous terrain to get above and behind tank formations, the T-55's limited turret elevation and poor roof armor became critical liabilities. The introduction of American-supplied Stinger Man portable air defense missiles and improved anti-tank weapons gradually eroded the psychological and material advantage that the T-55 had initially provided. By the mid-1980s, Soviet forces were replacing T-55s in frontline service with more capable T-72s, though T-55s continued to serve in rear area and support roles throughout the conflict. The T-55 did not exist in a technological vacuum. Throughout its service life, it faced a succession of Western and Chinese contemporaries, and the direct comparisons between these vehicles illuminate the fundamentally different philosophies that shaped Cold War armored power on opposite sides of the Iron Curtain. The most direct Western competitor in terms of production era and intended role was the American M48 Patton, and the comparison between these two vehicles encapsulates the entire Cold War debate about what a tank should fundamentally prioritize. The M48 was a heavier vehicle at 44 metric tons compared to the T-55's 36 tons. It carried a 90mm main gun in its original configuration, upgraded to a 105mm gun in the M48A3 and later variants, giving it a firepower advantage at longer ranges in the upgraded versions. The M48's armor was comparable to the T-55 in absolute thickness in some areas, superior in others. But the T-55's more aggressive sloping gave it broadly similar protection at a significantly lower weight cost. The M48 was significantly more expensive to produce and maintain, more demanding of skilled mechanical support, and far less suitable for mass production. In a war where one side intended to fight with thousands of tanks and the other with hundreds, the T-55's cost and simplicity advantages were not marginal factors. They were strategic realities. The British Centurion, in many ways the most capable Western tank of the early Cold War period, presented a different comparison. The Centurion Mark X, with its 105mm Royal Ordnance L7 gun, was arguably the finest gun-armed tank in the world through the late 1950s and early 1960s, with a fire control system and ammunition that gave it a real first-round hit advantage over the T-55 at combat ranges. But the Centurion weighed 51 tons in its fully armed configuration, consumed fuel at a prodigious rate, had a road range of only 100 kilometers without refueling, and cost approximately $300,000 per unit. It was an outstanding weapon for the army that could afford it and had the logistics chain to support it. It was useless for the armies of the developing world that needed armor on a budget. The T-55 filled that gap without apology. The French AMX-30, introduced in 1966 as France's answer to the T-55 threat, represented a conscious philosophical choice that prioritized mobility and firepower over protection. At 36 tons, the AMX-30 matched the T-55's weight almost exactly, but it achieved that weight by accepting significantly thinner armor on the basis that modern heat warheads could penetrate any practical thickness of conventional steel, making armor weight essentially futile. The AMX-30's 105mm main gun was superior to the T-55's 100mm weapon in firepower, and its suspension gave it excellent cross-country mobility. But field experience gradually demonstrated that the AMX-30's rejection of armor protection was theoretically interesting and practically hazardous, and the tank required multiple expensive upgrades before it achieved genuine combat credibility. The German Leopard 1, also introduced in the mid-1960s and carrying the same 105mm L7 gun as the Centurion, was broadly comparable to the AMX-30 in its design philosophy: excellent firepower, acceptable mobility, thin armor, and high unit cost. Against a T-55 force attacking in the numbers that Soviet doctrine envisioned, a Leopard 1 force would have had a qualitative per-vehicle advantage in firepower and fire control accuracy, but that advantage would have been tested against a quantitative disadvantage that NATO planners spent the entire Cold War trying to mitigate. The honest conclusion from this comparison is not that the T-55 was the best tank of its era in any particular individual capability. The honest conclusion is that it was the best tank of its era when the entire operational and strategic context was considered, when production cost, maintenance requirements, crew training burden, logistical footprint, and fleet size were all included in the equation alongside raw performance specifications. That is a more complex and more interesting conclusion than simply declaring a winner in a comparison of gun penetration values. But it is the conclusion that the historical evidence supports. Every weapon system that achieves genuine longevity has a core set of attributes that continue to deliver value long after its original design era has passed. The T-55 has several, and understanding them precisely is more useful than simply saying the tank was good. The first and most fundamental strength is mechanical simplicity. The V-55 engine is a direct lineal descendant of the V2 diesel that entered production in 1939. And by 1958 that basic architecture had been refined through 2 decades of continuous production, field use, and incremental improvement into one of the most reliable and field-maintainable power plants in military history. Soviet military doctrine explicitly valued the ability to perform major maintenance with tools and skills available in a forward combat area, without specialized equipment or factory-trained technicians. The T-55's drivetrain and automotive systems were designed from the outset with that requirement as a primary constraint, and the result was a vehicle that could be kept running under conditions that would have permanently immobilized more sophisticated contemporary designs. The second critical strength is the gun. The 100mm D10 T2S rifled gun is not the most powerful tank weapon of its era, but it is remarkably accurate for a manually loaded system, and its ammunition variety is genuinely comprehensive. With modern ammunition types, including later generation APF-SDS rounds, the gun remained capable of defeating the frontal armor of second-generation main battle tanks well into the 1980s, meaning that a properly upgraded T-55 with current ammunition was not hopelessly outclassed by significantly more modern opponents at typical combat ranges. The third strength is the low silhouette. At 2.40 meters to the top of the turret, the T-55 is one of the lowest profile tracked combat vehicles of its generation, and that dimensional advantage translates directly into reduced detectability, improved ability to fight from hull-down positions, and a smaller presented target area during exposed movement. This advantage does not diminish with age. A low-profile tank is equally hard to see in 2026 as it was in 1958. The fourth strength is sheer numbers. With somewhere between 96,500 and 100,000 vehicles produced across multiple nations, the T-55 family represents an installed base that no successor could afford to replace completely. Dozens of nations acquired these vehicles when they were inexpensive and available, and the economic reality of replacing them with modern equivalents has consistently outpaced the political will to do so. A T-55 in service today is not a sign of military weakness. It is a sign of economic pragmatism, and the extensive upgrade packages available mean that a modernized T-55 is a far more capable system than the specifications of the 1958 original would suggest. Honesty about the T-55's limitations is not a criticism of the design. It is a recognition that every weapon system represents a set of choices about which capabilities to prioritize at the expense of others, and the T-55's designers made choices that reflected the operational priorities of 1958, not the threat environment of the decades that followed. The most consistently deadly weakness in the T-55's combat history is the absence of a turret basket. Unlike Western tanks of the same era, the T-55's crew stood on the hull floor rather than on a rotating platform that moved with the turret. This meant that when the turret traversed, the loader and commander had to move with it manually or risk being knocked over by the rotating breach mechanism, a serious operational limitation during rapid-fire engagements that required multiple turret traversals. It also created coordination problems that slowed the effective rate of fire below the theoretical maximum. The second critical weakness is the gun depression limit of only -5 degrees. The T-55's hemispherical turret design, which gave it excellent protection against direct fire hits, could not physically allow the gun to depress further without the breach striking the turret roof. In practice, this meant that the T-55 could not fight effectively from reverse slope hull-down positions, one of the most fundamental and valuable defensive tactics in armored warfare. A tank that cannot depress its gun below horizontal while on forward slopes is a tank that must expose its entire hull to fire rather than just its turret, and that exposure dramatically increased loss rates in defensive engagements against opponents who understood the limitation and exploited it. The third weakness is the unshielded internal ammunition. The T-55's 43 rounds are stored throughout the fighting compartment in racks that offer no protection against the secondary effects of armor penetration. When an enemy round penetrated the hull and ignited the propellant charges, the result was catastrophic and almost always fatal to the entire crew. Western tank designs progressively addressed this vulnerability through separated ammunition storage and blowout panels from the 1960s onward. The T-55 never received an adequate solution to this problem within its basic design architecture. The fourth weakness is fire control sophistication. The basic T-55's optical rangefinding system, even with the later laser rangefinder upgrade, produced accuracy results at ranges above 1,500 meters that were consistently inferior to the fire control systems installed in late-generation Western opponents. In open terrain engagements at long range, a Leopard 2 or M1 Abrams crew using thermal imaging and ballistic computing could reliably achieve first-round hits at 2,500 meters against a T-55 whose crew was still attempting to accurately range the target. The thermal imaging deficit, which was never adequately addressed in any production T-55 variant, means that in any realistic modern combat scenario, a T-55 operating against a thermally equipped opponent at night is essentially fighting blind. The economic dimension of the T-55 story is inseparable from its operational history, because the tank's extraordinary proliferation was driven as much by price as by performance. The original Soviet export price of approximately $200,000 per vehicle in the late 1950s and early 1960s represented a bargain that no Western manufacturer could match. For a nation with a defense budget measured in tens of millions rather than billions, the T-55 offered a path to mechanized armored power that would otherwise have been impossible. The current market value of surplus T-55 tanks varies enormously depending on condition, variant, and upgrade status. A basic T-55 in serviceable but unmodified condition can be acquired for as little as $50,000 to $80,000 through surplus channels in Eastern Europe and Central Asia. A fully upgraded T-55AM or T-55AM2 variant with modern fire control, explosive reactive armor, and engine upgrades typically commands between $500,000 and $800,000 when sold through official national upgrade programs. For comparison, a new T-72B3 costs approximately $2 million, a T-90M costs approximately $4.5 million, and a German Leopard 2A7 has a procurement cost exceeding $10 million per unit. At those price differentials, the T-55 upgrade path remains economically rational for a significant portion of the world's military forces. As of 2026, the T-55 and its direct derivatives remain in active service with the armed forces of numerous countries across Africa, Asia, and the Middle East. The type has appeared in the ongoing conflict in Ukraine, where both Russian and Ukrainian forces have pressed elderly T-55s back into service when more modern equipment was unavailable, demonstrating simultaneously the tank's continued utility and the desperate operational pressures that make such a thing necessary. The image of a T-55 on a 21st century battlefield is jarring to observers accustomed to thinking of armored warfare in terms of Abrams and Leopards, but it is a completely rational response to the fundamental military reality that a tank you have is infinitely more useful than a tank you cannot afford. The Sukhoi Su-15 story that this channel told previously was ultimately a story about what happens when an extraordinary machine is trapped inside a doctrine that cannot adapt. The T-55 story is almost the exact opposite. It is the story of a machine whose fundamental design philosophy was flexible enough, simple enough, and capable enough to outlast not just the doctrine it was built for, but the empire that built it, the Cold War that defined it, and 3 generations of supposedly superior successors that were going to make it obsolete. What the T-55 tells us about armored warfare, in the end, is the same thing that the historical record of every major conflict tells us about military technology in general. Sophistication is not the same as effectiveness. The weapon system that wins on a specific test range in a specific set of conditions against a specific threat profile is not necessarily the weapon system that wins in the chaos, unpredictability, and resource scarcity of actual combat. The T-55 was never the best tank at anything except being useful. It was never the fastest, never the best protected, never the most precisely aimed. But it was available in numbers that no opponent could simply outshoot. It was maintainable under conditions that no other tank could survive. It was affordable enough to be fielded by armies that could not afford to field anything else. And those qualities, over 70 years of continuous service on every inhabited continent, have proven to be worth more than any amount of fire control sophistication or composite armor thickness. The lesson is not that simplicity always beats sophistication. It is that the weapon you can actually put in the field, in the numbers you actually need, maintained by the crews you actually have, is the weapon that shapes history. The T-55 shaped more history than any other tank ever built, not because it was the greatest, because it was there. And on some battlefield somewhere in the world right now, it still is. If this deep dive into the most important armored vehicle in history gave you something to think about, I want to hear your take in the comments. Here is the debate. Given everything the T-55 represents about the relationship between simplicity, cost, and operational effectiveness, do you think modern armies are making a mistake by racing toward increasingly expensive, technologically complex platforms that fewer and fewer of them can actually afford to buy and maintain in meaningful numbers? Put your argument below, because that is a question that has no easy answer, and I want to read serious responses. If this kind of detailed, uncompromising military analysis is why you are here, hit the like button because it directly tells the algorithm that content like this deserves to reach more people. Subscribe and turn on notifications because the story of Cold War steel does not stop here. The machines that defined an era and the doctrines that deployed them have more chapters left to tell. We will see you in the next one.